Right. Hello, everyone. It's second afternoon of the GSE UK virtual conference for 2024. Welcome to the Db2 stream again. I'm very pleased to introduce Mariella Viro, who's from IBM, an IBM Distinguished Engineer, and she's here today to talk about application modernization, consider those Db2 zOS capabilities. Please put the questions, any questions you have in the chat window, and we'll pick those up as we go along. And this is being recorded. And please remember to put your feedback in at the end. So without further ado, Mariella, it's over to you and good luck.
Yeah, so thank you for this very nice introduction. So this topic is very dear to my heart because it's so hotly discussed in many companies around the world. So which actually motivated me to put this presentation together. So I'm happy to share this with you. And this is really covering typical application modernization patterns that we see in C clients and approaches for application modernization. And then I would like to discuss what that would mean for data stored in Db2 for zOS and what capabilities in Db2 can actually help address requirements, challenges that come up in the application modernizations projects. And of course, I want to share some best practices on the way, and I'm open to questions as well. Just to very shortly level set, and you heard this, I think, already 1,000 times, the pandemic really accelerated the digital transformation around the world. Access to all functions via digital means became absolutely necessary. And here are just a couple of examples out of your everyday lives that illustrate the need for digital access to transactions that were in the past only accessed through account representatives or similar functions. So what does it mean in terms of application transformation approaches? We see three major trends, and I would see them almost in order. And this is a very high overview of it. So if you are an application architect, be patient with me. The three approaches are first API enablement, and that is the simplest approach to wrap your existing transactions, could be IMS transaction, could be KICS transaction, could be Db2 stored procedures or SQL or WebSphere transactions on C into APIs, so that the API consuming application doesn't even know that it talks to a C system, to a mainframe. And the popularity of zOS Connect as the program or the product that supports API enablement on C is a clear indicator that this is taken up almost in any company I'm talking to. The next approach is containerization. That is also very popular. We see how the adoption rate of the C container extension on zOS, as well as running containers on Linux on C as well. So this is a systematic move or packaging of and move into container that basically can run anywhere. So depending on the service level agreements for those applications, they can run on C or they can run on a distributed environment or in the cloud as well. So it's a best fit approach for the application. The last one, I think, is the most popular in conversations, especially in executive conversations. And this is implementing microservices and segmentation. But to be honest, this is also the most risky. And typically, it takes a long time to deliver value to the business. And you may wonder why this is all important to you when you have database focus. Every single of those application transformation approaches have actually an impact on your data architecture. And just talking about microservices segmentation, it requires a different database design, which is highly segmented, and it implies that the data is eventually consistent, not what we are used in C environments. And eventual consistency really requires a fundamental change in how data change operations are treated. And that needs to be clearly understood by the application architects. And I give you an example where I see that it's actually not clearly understood. So we had a conversation with a European company, and it's a financial institution, and they wanted to convert their transactions that create CDs into microservices. So when you look at what happens when someone creates a CD, you basically create an account, and then you transfer money into this account, which is then frozen for a period of time, and it has a committed interest rate. So the idea was, so they reuse the service for creating an account, and then they reuse the service for, or create a service for transfer money. In the existing transactions, this is all happening in one unit of work. With microservices, every service is a stateless entity, which means create account would be committed, and then you would go call the next service, which is transfer money, and that is independently committed. So if something happens with transfer service, maybe no funding or whatever, dozen things that could go wrong, then it's actually for a great CD an incomplete change, because the CD account is created, but there's no money in it, which contradicts the concept of a CD. So the client asked me how they can have a transaction across those two services. And I said, you can't. You actually have to code for every service that does something, does change. You have to code an undo service that actually undoes the change. And then, I mean, in the time where you do this, other transaction could go against the same data. So you have to understand how your data consistency looks and what is the impact on all your other transactions as well, that needs to deal with data that for a very short period of time is valid, but then it's not valid any longer, but it's still in the database. So I think it gives you an idea of the complexity of implementing microservices, and it's very easy implemented for retransaction, and you see a lot of those, but actually the adoption for change transaction is quite problematic. Which actually brings us now into the data aspect of it. You as a DBA or a data architect or supporting application projects, you have to discuss two fundamental approaches as in context of application modernization. So first one I already just mentioned, it's data consistency versus eventual consistency. And this is typically a very hot topic as soon as the application architecture adopts microservices and segmentation. You do not have this problem in API enablement because you basically build a wrapper around your existing application logic and data logic, and you may choose to change the implementation of a service later on to better structure your data in the database, but you can do it in an incremental fashion. Containerization is very similar. It builds on top of your existing infrastructure from a database design. So you are good there as well. But microservices, there needs to be a very serious conversation about this topic. The other big topic that is in discussion is actually data access of your existing databases versus replicating data into different environments. And that is actually a very hot topic, and pretty much every company I work with looks into this topic, because this is also a popular approach to move applications or services into the cloud. You have your operational environments, they run on C happily, and then new services are implemented in the cloud, and data is replicated to the cloud through different means, and then you have a different discussion. And without stepping on everyone's toes, but a lot of application architects I talk to think they have all the data aspects under control as well, and they know it all. But when it goes into the detail, they always assume that the data is available right now in the right form with the best performance, and we all know that is not the case. There are a number of implications that needs to be considered. So the first one is, of course, establishing a data replication pipeline is not technically a big challenge, and it's done once. But maintaining data replication pipelines over an existing period of time is actually quite expensive. And I know organizations who have whole teams just focusing on maintaining those replication pipelines, dealing with also operational issues. You just have many moving parts that all needs to be aligned in order to make it successful. Typically, it creates data quality and data latency challenges. This is what I mentioned. The application in the cloud or accessing the replicated copy assumes it's perfect quality and it's no latency. But in reality, even if the latency is a second, if you run a couple of hundred transactions per second, that is a lot of changes that could have gone into the data which is not visible in the copy yet. And if something goes wrong, or certain database operations are executed on the source system and not replicated, it creates data quality issues. So one typical example, you cannot allow any database operation that is not going through a log, Db2 log, if you use data replication, which is reading the data changes from the logs typically. So you can't do just an unload, you cannot do a recover, point-in-time recover. That will all invalidate your copy on the distributed or on the target side, and you have to take additional actions there. So I just want to leave you with a message. Both can be done, definitely, and companies do it, but accessing data in place is a much easier way to accelerate the transformation, and it delivers new value to the business in a much shorter period of time. So what I want to share with you now is actually the recommended way for an incremental IBM-C data consumption modernization. And this is very, very high level, very simplified, but around the world, I see this taken up and being implemented very successfully. And if you go back to your company, you may already be well on this path without realizing, yeah, you follow best practice. So it's basically 3 steps. And in this presentation, we just focus on the first one, modernize access to the existing IBM-C data. There are 2 additional steps that actually help to implement data fabric or data mesh, data architecture, including IBM-C data for making data available for data consumer or data consuming application. And those 2 steps would be virtualize or govern your data access across data sources and platforms. At that point in time, you are not just looking at IBM-C data, but data in other data sources, could be on-prem, other cloud data sources that are important for the data consumer to get a complete picture from what, responding to that business requirement. And the third one, satisfy complex information needs, is the hype now to the challenge to actually bring AI, infuse AI into the business critical service processing. And this in itself is a very hot topic. If your service processing runs on C, you have eventually the challenge to include or infuse AI into the service processes. And we have a very strong strategy on C with the C16 AIUs and machine learning on C capabilities, and more recently the availability of open source, AI open source packages on C as well. But I don't want to go any further in this than just showing it's modernizing access is just the first step in a bigger data architecture modernization, including C data. So let's look into what modernizing access to existing IBM-C data means. It's actually very simple. It's bringing your existing data into a form, into an API form that is consumable by pretty much all application environments and application languages. And you can break it down to 2 things. One is SQL, and the other one is REST. And with Db2 being a relational database, SQL is a no-brainer, and you can use SQL to access Db2C from local application and remote application and pretty much every language you can think of. And we get to that topic in a second. If you look into data that is stored in vSAM or IMS, the same functionality is actually provided by the data virtualization manager for zOS. So that basically maps your existing structures in vSAM or IMS, and it supports other data sources as well, but let's focus on the most common one, and maps them to relational views, and then you can have SQL executing over those, or it's also REST, supporting REST. The Db2 Analytics Accelerator actually plays an important role here because it is able to transform data via SQL with very high performance to make it better fit to the services that to serve the data to the new services. So a lot of companies picked this actually up as a use case for the analytics accelerator, even if this was not the first intended use case, but it really serves the purpose. Overall, this steps really makes this existing data sources, which should have the highest data quality for new application environments, and therefore reduce the risk. So, focus can be on the application logic and not on a completely new data architecture. And of course, it also increases the data quality, or the quality of the data that is provided by those new services. So that is context why we are looking into the functionalities that I want to cover now. And the first one is obvious, I think. I want to point out the Db2 native RESTful service support. That was a functionality that was picked up right on day one of its availability. It's very widely used, but surprisingly, I just went to a company in the US a few weeks ago, and I talked about the native REST support in Db2, and they had absolutely no clue that this exists. So I want to point it out as a second alternative to access Db2 for zOS data. You can have service calls directly to Db2, so it would connect to DDF, or it could also connect, the API could connect to zOS Connect, and zOS Connect then would talk to DDF and pass through the API requests. And zOS Connect can do some additional mapping, and it also has the open API support, which Db2 doesn't have. So there are all real values in using zOS Connect in the middle. Fundamentally, how it works, you have an SQL statement at the end, which is your service implementation. And of course, you talk about services that are data-centric with very little business logic. If you want to combine multiple SQLs into, then you would need to code them in a stored procedure, doesn't matter which language. And then the call statement to the stored procedure becomes implementation of the service. So you create a service out of this SQL. And then as an input, you just get an HTTP or HTTPS request with the IP address of DDF and the service name, and in the JSON payload is the input to the SQL statement. In this example is like this ID with a number, with a value of 1, 2, 3, 4, and so on. And then the response is coming back as an HTTPS response package to the application. So from an application perspective, it's an API like any other. They wouldn't even know that they talk to zOS, that they talk to Db2, or that the service implementation is actually an SQL statement. It has quite a number of benefits. The first one, the implementation reuses DDF functionality, which is proven since and improved since and optimized since decades now. So it's highly available, highly scalable, highly serviceable. To be honest, I know very few Db2 environments that do not run a significant amount of their workloads through DDF. The other one, DDF provides the security auditing, all of this, and data transformation, of course. So DDF transforms JSON payload into the data formats that the SQL would expect in order to execute it. We follow our own best practice to use client info fields, which is a very powerful information for problem determination, performance analysis, you name it. It supports both HTTP and HTTPS, and I think there's a CPROM now that actually enforces to only run on HTTPS, because this is required by some, especially financial companies now. It's zip eligible like any other distributed workload, and I think what is a key point here. From a usage pattern, you want to authorize a user to execute a service, which is really a static authorization model. And RESTful services implement the static execution pattern. So you have the service package, and you allow users to execute those service packages. But the authorization checking, object dependency tracking, all of that is done like any static SQL. So a service package would go would be invalid and could be determined by a DBA if the underlying SQL has a problem, or the DDL changed, or any change operations that would invalidate a package similar to any other application package. And you have a catalog table. It's this IBM DSN service, which helps to manage those service packages. So what I want to leave you here, without doing a really detailed introduction, having RESTful services or providing data to front-end application that does need very little business logic, like looking up user information, looking up account information, looking up whatever. You don't need a middleware application transforming an API into an SQL statement. Just API enable or REST enable the SQL or number of SQLs in a stored procedure, and get it back to the front-end application, and you're done. It saves in maintaining environments, maintaining applications, less moving pieces that could go wrong, and as I said, very high performance, scalability, and very secure. Okay, so this is RESTful server support, which is, I think, obvious when I talk about modernizing access to C data, especially now focusing on DB2C. The next topic is actually also very, very hot right now. We have a new offering, which is the Watson Code Assistant for C, which helps application modernization projects by analyzing the structure of applications, and it also uses large language models to help with the transformation from COBOL application, COBOL logic, into Java logic. But even before, quite a number of companies actually adopted Java as their new programming language to implement back-end business application, business logic. But I did a little study to approach a more, or have a more holistic approach, and looked at what are the popular programming languages and authors available on zOS, and how is support accessing data stored in Db2 for zOS. And you see here, Java has the most developers worldwide, or developers with Java skills. Python, Node.js, and Go are the next one, and all of those are supported on C. So there's no reason not to run application on C, because they are, the architecture guidelines require them to implement in one of those new frameworks. They are all available on C. And then I looked up my very old pictures that shows how different application programming languages access Db2 for zOS. And I actually did another Google search, and Forbes had a list of the top 5 programming languages that were most in demand in 2023. And it started with Python, followed by JavaScript, Java, .NET, and PHP. And you see all of them are supported, all also supported languages, accessing Db2 as one of the IBM data servers. Java, of course, uses data server driver for JDBC and SQLJ, and the other languages mostly go via the CLI or ODBC driver. So I call it typically the C-based driver. Which brings me actually to a new exciting functionality. Actually, part of it is new. If you run your application on C, you would, following our recommendation, you would typically use the Db2 for zOS type 2 or the data server driver type 2 that runs on C and comes with your Db2 zOS license. So there's no additional licensing cost if you do it on C, if you run it on zOS. And many years ago, I mean, almost decades ago, we supported sharing of the connection to Db2 between a COBOL application and a Java application in WebSphere, Kix, later on in Kix as well as IMS. So if the application is modernized module by module, you could have one module still implemented in COBOL, selecting some data, and then another module is in Java, and it would update this data. And if you could not share the connection, you would have to go into a two-phase commit protocol, which adds significant overhead for the transaction. So by sharing the connection, you stay with a single phase commit, and the performance and scalability basically is maintained from what you're used to in your COBOL environment. So the new support is actually bringing this functionality into zOS batch jobs. This is I see it as a phase 2 of application modernization. For transaction, it was very modular. You could incrementally transform the implementation of a transaction, but no one really wanted to touch the batch jobs because this is very complex, fully automated, etc., etc. But now the desire is to actually reuse some of those Java modules in the batch flows as well, and then you end up with a similar problem to that you have a batch job, a single batch job that has some components in COBOL or in Java, and then also in the other language. So this is an example how it looks. In this example, a COBOL program calls a Java program, and Java both supports 31 and 64-bit. And I think because this is all new stuff, the companies I know actually just go with the 64-bit Java environment. So this JIB stands for Java in batch. And as you see from a flow, that if you start with a COBOL program, eventually this COBOL program has, remember we are in batch, there is no standing JVM like you have in WebSphere or in Kix. In Kix, you would start up your Kix transaction manager, you start up your JVM, and it sits around and it can just be reused. In batch, you don't have this environment. So your first call to a Java program actually initializes the JVM. And if you choose to, you would call this chip init method, which actually initializes your connection to Db2 to be used in COBOL as well as in Java. And then you can execute an SQL statement from your COBOL program, you can execute it from a Java program, and eventually when you reach the end of the transaction, you are not calling a DB2 commit, you call a chip commit, which comes with a package or a rollback. And that would end the unit of work in DB2 and consistently gives the information back to the LE environment. And at the end, you would do a chip terminate. So that's which basically brings down the DB2 connection in an orderly fashion before the batch shop closes. So this is how it works. I know already quite a number of European companies are really, really interested in this, because this is the last big part of that they need to tackle in their modernization journey. With Watson Code Assistant or manual, this is a very hot topic. So because it's so hot, actually you see the last PDF that PH58890 was just delivered few weeks ago. So it's very, very recent. And I also added the link to the Java interlanguage batch. If you follow this link, it brings you to the documentation, which has all the details in it. Okay. With that, I go to the next topic, and this is interestingly it was a very popular feature, and then it became a little quiet, and I don't know really why. But this was the need to load data from distributed system back into DB2 for zOS. And typically, this problem happens as part of your modernization journey. So some of the data is moved to a different system, and then new applications change those data. And then, of course, the core systems that still run on C, they need this data back in order to function. So clients had desperate need for an efficient way to get this new updated data from the distributed environment back into DB2 for zOS in order for the existing transactions to still, or transaction workloads to still function properly. So traditionally you had, of course, unload load, or some people actually wrote applications that just would take the local data and then issue SQL insert, or even multi-row inserts to make it a little more important, or use cross-loader if the source was in DB2 AUW. But actually, since DB2 12, which is going out of service next year, so it's already old, we support the DRDA fast load. And that is actually very cool, because you de facto call a load utility from a distributed application. And this is just an example out of a Java program. You can also implement it in C. And you see that the first load statement, that is, you recognize it. It's your sysin card from your load statement with all the settings that you use, like pre-format, log no, reuse, whatever. Whatever you use in your current load statement. Then the second parameter is your input data file on your distributed environment. And then you give it an identifier and call for Java, it's a cload method on a DB2 connection and provides those input statements. So DDF would establish a connection to the load module, and then it uses actually a service to continuously load those blocks of data into the database. So A, it's very high percentage, and B, it's even faster than a local load, to be what our performance numbers showed. So it's extremely efficient in getting massive amount of data back into DB2. So I want to keep this awareness. You see down here the comment used by SAP. Actually, SAP is using this to get data, change data back into DB2 as well. Okay, so the next functionality, and I have to pay attention to time, otherwise I talk 2 hours here.
Mariella, just a quick point on the chat. Somebody has Duran has mentioned that in a previous presentation, somebody mentioned that calling Java from COBOL had performance implications and it was not a good idea. Have you heard of that issue?
No. No, seriously. I work with companies who, I mean, they are really well on their transformation journey from COBOL to Java, and they do this very successful at a very high scale. So,
Right.
so I would say, of course, if you run Java as an object-oriented programming language, it has implication on the performance. That is the reason why part of the Java code is actually zip eligible to compensate for that. So your COBOL program is really efficient. But with the compensation on and zip execution, plus numerous enhancements in new instructions, optimization in the JVM, optimization everywhere. I think running Java on C is now the most performing platform for Java applications. I think this is not a concern for me any longer. I have a different presentation on best practices for high-performing Java applications accessing DB2. You can do some mistakes that create quite some overhead, because with the object creation, etc., you can magnify problems if you do not follow the best practice. But overall, I would not share this concern at all.
Okay, thank you.
Okay, and I just realized there is a chat window, but thank you for the reminder. Okay, so let me see, how do I get? Oh yeah, no. So the next 2 topics, I really just, in interest of time, touch them, is requirements to keep more data in the application for different reasons. Application logic reason, regulatory reason, you call it. The first one, and if you modernize an application, meaning you at least rewrite part of it, is a good opportunity to revisit this technology. I worked a while ago with a company. They finally made the step of moving the data from vSAM into DB2. This is another big opportunity to review how to deal with historical data or archiving inactive data. So the first one, I just want to remind you, DB2 temporal is great and very, very efficient to keep history of all the data changes in a database. And this should also be considered in the context that the data consumer nowadays want to have current data. And we did actually an analysis on data transformation pipelines and found out that up to 70% of the processing of those transformation pipelines is actually to find the history of the data after the fact. So if the different teams, the data architects for analytics use cases and the operational data owner would collaborate, I mean, just implementing the system temporal, system time, keep history of the data, use temporal queries to get point in time, analysis that then can be extracted and moved into other platforms could cut the data transformation pipelines in half, and from a time perspective, from a complexity perspective, etc. So using DB2 temporal, especially system time, is not just interesting for the operational application itself, but it's also interesting to maintain data history in support of the data transformation pipeline and make data available to data consumers for AI, for reporting. And as I mentioned, this is now the game changer for being most successful in your business is adopting AI. And so this is a critical foundation where we can actually help from a DB2C perspective. So I don't want to go into the details. Business time is actually really reflecting the reality that for specific time intervals, the data changes, and the changes are ahead of the time in the database. So actually, most companies in their schemas already have a valid form 2, for interest rates, for certain contracts, pricing in the distributed, everything which is limited to specific time periods. The business time is a really important functionality. So the other approach, which is somewhat a subset of the temporal, is actually transparent archiving. And it's interesting, this topic came up in the last, let's say, 6 to 9 months. It very frequently, it has a renaissance, which for me, it's interesting because it's a regulation how to deal with archiving data, how long data can be archived or should be archived, what is the retention periods. It's all defined in regulations around the world since a number of years now. But, my personal opinion is that, the global change is now reminding, the political change, I think, motivates clients now or companies to actually enforce those laws, whereas before they were more lenient. So I went to Asia Pacific and this topic was discussed. It's revisited in a number of companies in Europe. As well as just a couple of weeks ago, I had a conversation in the Americas, how to separate inactive data, how to archive, and how to enforce retention as well. So I think the biggest topic from a performance and cost perspective on DB2 is actually the focus of separating your active data and your inactive data. And inactive data is accounts that got closed, claims that were processed, products that are not sold any longer. You still want to keep them, and there are business reasons why you need to have access to them from the application, but you really don't want them intermixed with your active data for 2 reasons. One is from a data maintenance perspective. Your image copies are bigger, and if you have inactive data that is not changed as frequently or not at all any longer, you don't need to take image copies as frequently, you don't need to reorg, you don't need to run stats. And so you can focus on a much smaller percentage and do it more frequently and still save significant cost here and processing time. What is the most important part from my perspective is the availability aspect, because if something goes wrong and you have to recover, of course, you would be happy if your data size that you need to recover is only a fraction, because you only recovers active data, and all this inactive stuff, is first it can go as a second priority, and second, it may not be even available to get business critical applications up and running again. So the data maintenance is one aspect, but it also has a significant impact on performance, because just think about you have your table clustered by accounts, and your account has inactive claims or closed claims, or from in the healthcare industry or insurance industry, or it has closed accounts from, talking about those CTs that were, valid 10 years ago, and it still sits in the system. You have all of this rows in your pages. So when you load the pages into the buffer pool, your buffer pool hit ratio is very low. You have much more I/O. Your index trees are much larger. So instead of a 3-level index tree, you may have a 4 or 5-level index tree. So every time you try to access a data record, you have to traverse more index pages to get to this leaf page compared to when the index tree is smaller. So even for your day-to-day transactions, separating those would be beneficial. And the Db2 archive transparency is actually helping here. It uses a 2-table approach. You have in your archive enabled table, you have all your active data. Everything is nicely dense and optimized. You may have different indexes on it. And as soon as an archiving criteria is reached, like a claim was closed 6 months ago, then it goes into the archival. It's moved into different set of tables. You can have a different table space organization. Everything is different, and only the use cases that actually need to go back to those inactive data that uses then the global variable get archive to actually include this old data as well. So there is also a ZPOM move to archive default, which means you don't need to set a global variable move to archive for each table. If you set the ZPOM, Db2 will recognize for the tables that have a pair of archive and archive enabled tables, and will do the archiving automatically when you do a delete in a unit of work, or you can also do a reorg, discard, and load into the archive table as well. So I think this is, again, a Db2 functionality that for whatever contents becomes more popular recently, and it's definitely worth revisiting. So the last functionality I want to cover is mostly focused on distributed application, but with Db2.13, we actually also introduced the first use case for local application, and this is the system profile monitoring. And there are a ton of use cases, and all are real. Manage migration to new driver levels. You can set in the profile monitoring what level of driver you want to support and which one you want to give a warning. And you can actually set an exception and disallow as lower non-supported driver levels to access Db2 any longer. Prevent workload with denial of service characteristics. That it doesn't happen frequent, maybe once, twice, three times a year, but when it happens, it has a pretty severe impact for the system. It means that the most frequent example is that programs don't test their error path very well, and then they run into an error, go in an exception mode, and then they, in a tight loop, just feed new or fire new connection to Db2 and basically push all well-behaving applications out of DB2 by hitting max dbats, hitting the max connection number. It's typically not a nice experience. So this is a very effective tool to give the applications the resources they are allowed to have without taking over the entire system. Special register setting, so it's definitely used to route workload to the accelerator. You can set the global variable for transparent archiving, which I just discussed. And in version 13, we have the influence that you can influence as timeout and deadlock behavior, who's the winner and who has to give, which was previously a decision of DB2. So just a short example here, number of connections could be set, number of threads, timeout value. Timeout value is a really important one because we have the timeout settings in CPOM, which is typically set to 120 seconds, which is already a long period of time in today's workloads. And there's one not so well-coded application that can't deal with it, and then it's set to 0. So an important safety net for DB2 is actually disabled. With the system profile monitor, you can set the timeout value for this one application to 0, but keep your standard in place for all the other applications. So I already mentioned special registers and global variables and the support for local threads in DB213. So really, really important functionality for you as DBAs and SysBox to manage how the system is, manage the gates into DB2 to be safe and have a very high service levels as expected by our business. With that, I want to summarize. Application modernization is actually, it's everywhere. And as always, it's a challenge and an opportunity. So it's a challenge because of the change, but it's a great opportunity to use functionality that was delivered in DB2 with the more recent versions. Just remember, incremental modernization delivers value to the business much faster with very manageable risk. I see this as a very successful way in companies who adopt it, whereas some companies try the greenfield, develop everything from scratch, and typically it takes years, and it's before the business even sees something, and it's very, very expensive. Just remember, application modules can be implemented in different programming language, basically any language that's supported in LE and Java. A lot of popular languages are supported, I mentioned that. And then think about REST services, that they are stateless, and the optimization of one-phase commit with shared connection versus otherwise two-phase commit that is necessary. Efficient load from distributed platforms via the DRDA load, and then the temporal functionality and the profile tables. And with that, disclaimers, and I think we are out of time. So please submit your session feedback, and I just learned and corrected my session code is 6K. So let me see if there are any more comments or questions. If not, I think my email address is in the presentation. If you have questions afterwards, just feel free to send me an email.
Okay, that was brilliant. Thank you, Mariella. If anybody's got any questions at the end now, post them in the chat, or I think I've given everybody permission to unmute themselves if they've got any questions. I'll wait for a couple of seconds. Don't think there's anything coming through, Mariella, so thanks very much indeed for that. Just to let everybody know, on the DB2 stream at 4:30, there's a linked session, actually. It's about DB2 for zOS and REST access with Tori Felt. So that kind of feeds into this session. So if there's no other questions, comments, thanks very much, and have a coffee break. Come back for the 6:30 session.
Okay.
Sorry, 4:30 session. 4:30, 16:30 session. Yeah.
Yep.
Okay. Thanks so much,
Thank
Mariella. That was
you.
really good. Thank you.
Yep. Bye.